Today I want to dig deeper into the native SteamVR driver software for the Dream Air made by SBoys3. In the previous video, we briefly announced that the first release of this driver now supports Pimax, and I assume that if you have a Dream Air, you may already use it. But for those of you still waiting for your Dream Air arrival, I want to quickly go through the available options and adjustments in the bundled software from the SBoys3, which is called Custom Headset. I want to simply make you familiar with it, explaining what the different options do and how they can help you to configure and optimize your headset. And some things are really cool. How about getting 100% binocular overlap with just one click? Or to some degree extend the field of view with just another click with your mouse. This is amazing in my opinion, and it also demonstrates how powerful this custom headset software and its SteamVR driver really is, and why I'm hyping it so much, and why I'm encouraging you to support SBoys3, the creator of this app, for his incredible work. But let's not get ahead of ourselves. Let's start off from the beginning and go through all the settings one by one. First off, there is no need or even a way to install this software. You simply download and extract the zip file anywhere you like on your PC. The current version is beta 1.2.0 and the zip file contains two folders, Custom Headset GUI and Custom Headset OpenVR. The GUI, which stands for Graphical User Interface, is the custom headset software itself, or the exe file. The second folder contains just the drivers, and of course all you do to get started is to just run the exe file. Preferably create a shortcut to the file on your desktop or the taskbar for a quicker access. First time you enter, you will see that the native SteamVR driver is not yet installed. In the About tab on the far right side, you can install, reinstall and uninstall the driver within seconds. Also, you can check for updates for new versions coming up. Once installed, you can immediately boot up the headset into native SteamVR mode with the Launch Dream Air headset button. Before you do, always make sure that the enabled Dream Air driver right below is on or enabled. As I said last time, yes, before you launch your Dream Air with this driver, you will first need to have the headset connected with Pimax Play. This is due to the current Pimax DRM restrictions, and the headset needs to be initiated by the Pimax Play at least once after your PC or Windows has restarted. Once the native SteamVR driver is active, Pimax Play gets disconnected from the headset, but you cannot completely close it down. Just minimize it and forget about it for now. So there we go, we're up and running with the driver, and obviously SteamVR gets launched automatically, and of course if you shut down SteamVR, then your headset goes into sleep mode. Starting up SteamVR will wake the headset up again, and if you for some reason want to switch back and connect to the default Pimax Play runtime, you will need to restart the service in Pimax Play. Oh, and one more thing before digging into the options. If you disconnect your Dream Air cable while the native SteamVR driver is running, then SteamVR will thankfully not shut down. It will wait until the cable is reconnected, and it will, within seconds, resume SteamVR and hopefully also the game that you're playing like nothing has ever happened. And if you ever need to quickly restart the SteamVR driver or the VR compositor, you can do that from the About tab. Okay, so on the main page or the driver settings tab, you will see all available options and customizations. I already mentioned it before, but there's currently one available distortion profile for Dream Air only, having a default max horizontal field of view of 100 degrees and max vertical field of view of 86 degrees. Yes, it can be changed and expanded to wider field of view later, but let's not get ahead of ourselves again. And no, you are not supposed to use the Megan X profiles. I mean, you can, potentially, but the profiles are totally different and you will get tons of distortions and warping since Pimax lenses are completely different. Then IPD adjustment. No, this is not the hardware or the physical IPD adjustments for the Dream Air. This is the software IPD, or the IPD for the SteamVR virtual cameras that renders the image in its pipeline. The value do not need to, but should somehow match your physical IPD for optimal eye comfort. If you have determined that your IPD is, for instance, 69.5 like mine, then you should set both the physical or the motorized IPD to 69.5 and same for the software IPD. As of now, the only way to set physical IPD on Dream Air is through Pimax Play. So yeah, make sure to do that before you switch to the native SteamVR driver. The next two options are very handy. Here you can, even in real time, customize both the horizontal and the vertical field of view, all the way from max literally down to 1 degree. And you see the results in VR immediately, in-game. I would call this a field of view crop tool, meant to lower the field of view from the profile's max values. And what's most amazing about this feature is, as I said, the changes are made instantly, whatever you're playing or running with SteamVR. There's no need to restart anything like SteamVR or the VR compositor or the game itself. So if you use this to gain performance by lowering the field of view, let's say vertically, when running racing simulators specifically, you will see the performance gains or the higher frame rates instantly. Crazy, isn't it? I mean, I do have a video in the works regarding this topic with some benchmark results coming soon, so stay tuned. Right below the field of view adjustment sliders, you can view the details about the current rendered field of view and the current resolution per eye, which is based on when having SteamVR render resolution set to 100%. Here you can also see the recommended resolution for a 1:1 sample per panel pixel, which is, in my opinion, kinda overkill and unnecessary. In fact, the default resolution of 4015 by 3396 pixels per eye at SteamVR resolution set to 100% is surprisingly good looking with very few jagged edges visible. This is a very impressive distortion profile from SBoys3, I think. Especially if you play casual VR games like shooters and similar, I don't think you will ever need to go further up in resolution from here. For simulators, on the other hand, like DCS World or Microsoft Flight Simulator, I tend to settle at 150% in SteamVR, making the per-eye resolution higher and very close to the default Pimax Play render quality set at 1.0. This will indeed bring out the fine extra details in cockpits at far distance, while eliminating most visible jaggies or aliasing, but yeah, it will also lower your performance or frame rate. The field of view zoom affects the VR image by simply zooming in and out the rendered view. Very helpful when wearing glasses that limits your field of view, for instance, and by zooming out a little, you will be able to see the entire rendered field of view within the area that's possible to see through your glasses. You can also adjust this if you want to correct your view depending on how close you want to get to the lenses with your eyes, maybe when using different facial interfaces or custom face masks. Bear in mind, this will somehow affect the world scale and the rotational axis pivot or the fixed point of rotation when you move your head around. The more you adjust, the more it can feel off. Although when combined together with the distortion zoom slider right below, the image can be tweaked to correct the view and the rotation to a certain degree at least. Very useful sliders, and I do recommend you to play around with these, at least in case your VR view feels a bit off, and especially if you wear glasses, contact lenses, or use the prescription lens adapters with lenses for the Dream Air. The parallel projection switch is new and wasn't available before this public first beta release. It can be enabled and disabled in real time while in a game. Most games don't need it, but some do require parallel projection, such as Le Mans Ultimate, for example. If you run it without this option enabled, you will get extremely cross-eyed view. I can simply explain that this is related to the canted panels most Pimax headsets have and the way the VR image is rendered to correct that. As far as I understand it, Pimax Play has parallel projection always enabled by default to simply eliminate the risk of a game starting up with a cross-eyed view. It's convenient and a safe approach, but there is a downside. Parallel projection does increase the total rendered resolution. So no matter what you play using Pimax Play as a render pipeline, it will render with parallel projection enabled, many times completely unnecessary when the game doesn't need it. So here instead, with the native SteamVR driver by SBoys3, you have the freedom to switch it manually on only when required. The color tint options freely adjust the hue, saturation and vibrance from the default 0 values. Nothing new here really compared to how Pimax Play does it, but I must say that the vibrance slider is surprisingly efficient to increase the overall brightness of the scene. At least if you do it with small adjustments. Pushing it too high will blow out the whites and negatively impact the contrast. It depends on the scene of course and what you actually play in VR, but I definitely prefer having vibrance or the V value on 1.25 over default 1.0, giving a more punchy, brighter image that feels more alive in general. The stationary dimming settings are there to automatically dim the micro OLED displays of the Dream Air when the headset is temporarily not in use, when you just take it off and put it down on the table. You can customize it according to your preferences in more ways than both the Pimax Play and SteamVR allows you to. You can choose how quickly it should dim the panels, how much it should dim it, and many other variables. It is there to eliminate the risk of OLED burn-in that isn't really common, but still possible if you render a static image over longer periods of time. The hidden area mesh setting is similar to the hidden area mask setting in Pimax Play, but here you can also customize the mesh freely from all sides and corners of the view. This feature is disabled by default, and if you enable it, it will mask out corners and edges of the view that are physically not even visible in VR anyway, due to multiple physical factors. You can also specify the mesh detail level, making the mask edges rounder and more natural if you increase that value. Note that you need to restart SteamVR or the VR compositor at least to actually see the difference between enabling and disabling this option. Okay, further down, we have the black level slider where you can set the minimum brightness level of the micro OLED panels if you for some reason prefer not to see the complete pitch black darkness in VR thanks to micro OLED technology. Anything above 0 will prevent the pixels from completely turning off and the minimum black levels will be worse. Or brighter, I would say. Kind of an LCD effect when using micro OLED panels. Sounds completely useless, but I guess there are specific use cases when this could be applied to bring out more details in very dark scenes. The IPD offset will apparently be removed soon, so we're not going to talk much about it, because the IPD adjustment on the top of the settings page already includes the offset extremes, making the full range go from 50mm all the way up to 80mm. Subpixel shift is nothing you should touch unless you know what you're looking for. In short, it will shift the subpixels, potentially improving or lowering the amount of chromatic aberration or color fringing noticeable in the peripheral view area, especially around sharp edges, small details and readable text. The default value is what's optimal for the Dream Air Micro OLED, and I think most of us will never feel the need to change that value since the chromatic aberration already is very low on the Dream Air. Distortion mesh resolution determines the detail level of the optical distortion correction mesh or pattern. At default 127, it's already optimal. The field of view burn-in prevention checkbox enables a feature that will randomly change or increase the extreme ends of the field of view by just a few degrees to prevent burn-in on the panel edges. I guess this is mostly useful if you often crop the field of view, especially vertical field of view, with the settings we touched earlier in this video. The next two sliders, render resolution multipliers separated with width and height, allow for resolution values above and below the possible range between 20 and 500% in SteamVR resolution per eye sliders. And that is done independently for the vertical and horizontal resolution. This could be handy if you want to go below 20% or above 500% supersampling. Maybe also when you want to prioritize horizontal render resolution over the vertical, or the other way around, of course. The next three options are only for advanced users that really know what these adjustments are meant for. I'm talking about supersample filter percent, seconds from VSync to photons, and the third one, seconds from photons to VBlank. Especially the latter two are things you simply should not touch unless you know what you're doing. Because worst case, you can mess up your VR experience pretty badly, creating tracking issues or image-related problems. Now, eye rotation option is way more interesting than it sounds. This is also one of these values that I have been messing around with previously when building custom field of view profiles for Dream Air and Super Micro OLED with the help of AI. In short, eye rotation affects the toe off, which can offset the rotation or the separation of the viewpoints per eye. With slight adjustments, we can manipulate the VR view to actually increase the rendered field of view at the cost of binocular overlap and vice versa. Yes, we can increase the binocular overlap too, or even maximize it to 100%. Yep, that's depth max or a max depth that I've already mentioning so many times before. The default value here is 2. Now, just by lowering 2 degrees down to 0, with the current default Dream Air distortion profile that SBoys SteamVR driver is using, we get 100% binocular overlap with just one click. In fact, this gives us a VR image pretty close to the depth max profile I created for the Dream Air with the help of AI not long ago, having roughly 100 degrees horizontally with 100% overlap. I mean, it's pretty cool, right? Finally, with just one click, you can play around with this field of view and binocular overlap in real time. And yes, you can of course increase the field of view this way, but only to a certain degree. With better base distortion profiles coming up, I think we can easily achieve a field of view of let's say 115 degrees horizontally and maybe even higher by just changing that value to maybe 3, 4 or even 5. As of now, since we only have one profile to work with for this driver, the maximum field of view is a bit limited, and if you push that value too high, the separation also becomes too large, making your eyes feel kinda uncomfortable or a bit cross-eyed. So yeah, it will affect your eyes if you go too far, so be very careful and only make small adjustments to begin with. I think the value 0, creating 100% overlap, should be okay for most people to handle, and already now the 100% overlap feels really great. Now, at the bottom of this driver settings tab, there is a disable eye option where you can simply mask off the entire view and make it pitch black for each eye individually or both eyes. I'm sure that there are special use cases for this feature, maybe when testing sharpness and readability per eye when viewing, like, let's say a Snellen chart in VR, for example. Now, the remaining tabs are pretty obvious, such as the distortion profile tab. Once we have other Dream Air profiles that are not automatically built into the app, we can simply import them from here. Moving on, in the app settings tab, you can change between a dark and a light theme of the app and adjust some general settings. In the About tab, we already saw that we can install, reinstall and update the native SteamVR driver, as well as restart the VR compositor. And lastly, below is something maybe just as important. Here you'll find the links to support SBoys3, the creator of this app and this native SteamVR driver. And I cannot emphasize enough how important it is that we all support him and hopefully keep him motivated and encouraged to continue developing for Pimax, including support for other Pimax headsets than the Dream Air. Fingers crossed. So support him the way you can, buy him a coffee or a Lambo, it's all up to you. I'm sure he will appreciate it a lot, just like we all appreciate his contribution. And with all that being said, this is all I have for today. Stay tuned for new updates coming up and more videos here on the Pimax official YouTube channel. Leave a like on this video, let me know what you think. Thanks for watching as always, and I'll see you in the next one.